Welcome to my teaching channel. This is the last video of data cleaning and manipulation part 2. In this video, we are going to talk about missing values in social survey data and how can we deal with missing values using Stata. So before we start, make sure that you have 3 files on your desktop. The first one is SOC5070 stata1 and 2.do. This is the command file. And in addition to it, we have missing example.xlsx. This is an example that I'm about to show you the so-called missing pattern in your data. And then we are going to use GSS 2014 partial.dta as the demonstration data. So let's double click on the missing example.xlsx and have a look at the so-called missing pattern of social survey data. So see, this one demonstrates you some possible situation that you may face in your survey data. Let's suppose totally we have 7 respondents, and each one was required to answer 4 questions. Question X1, X2, X3, and X4. And in this raw data, it looks like that the respondent number 1, he or she was very cooperative and provided 4 valid answers to 4 questions. So for case number 1, there are totally 4 valid answers from 4 questions. For the second respondent, he or she provided 3 out of 4 valid answers to 3 questions, okay, and he or she refused to answer the first question. Maybe refused, maybe this question is not applicable to this specific respondent, and totally there are 3 valid answers from the second respondent. The third respondent gave only 2 answers to question 3 and 4. For question 1 and 2, this respondent provided missing values. So totally there are only 2 valid cases. And for respondent number 4, he or she answered only the last question, and as a result, the value for the first 3 questions are set to missing. So there is totally 1 valid answer. For respondent number 5, he provided 3 valid answers, and he or she refused to answer the second question. For respondent number 6, question 2 and 4 were set to missing due to refuse or inapplicable. So the valid answers from respondent number 5 and 6 will be 3 and 2 respectively. Finally, we have the respondent number 7. We got no valid answer from this respondent. So all 4 questions were set to missing. So the total number of valid answers for respondent number 7 is 0. We learned that in the first part of data cleaning and manipulation, when we use the command gen to generate a new variable, for example, the sum of 4 answers. By default, Stata will follow a so-called list-wise deletion, a way to deal with a missing value. That means if any question was set to missing, then the calculation result will be missing. So if we use the list-wise deletion, respondent 1 will have a valid result of summing 4 values together. So 1 plus 2 plus 3 plus 4 reaches 10. And for all other 6 respondents, due to the existence of missing at least 1 missing value, actually, the calculation result will be set to missing. So how about we want to get the result of the sum of values from 4 variables, and then we treat missing value as 0 so that we can get a valid result. So for example, for respondent number 2, if we follow the list-wise deletion way, the calculation result will be missing because for this respondent there is one missing value. But if we follow the second way, where we treat the missing value as 0, then we can go ahead and sum up 3 valid answers together and reach a valid calculation result. For respondent number 3, we treat first 2 missing values as zeros, and then we can get a sum of 2 valid answers from the third respondent. For the respondent number 4, there is only one valid answer here, so we simply treat this only valid answer as the sum of the respondent number 4. We use the same idea to deal with respondent number 5 and 6, so that we can have 8 and 4 as sum of their valid answers respectively. For respondent number 7, because this case provided no valid answer at all, so we should set the sum of to missing for this respondent number 7. Okay, so actually the second way of putting things together, putting numbers together, is better than the list-wise deletion way. And I think in the second way of dealing with missing values, you can save a majority of your cases. We apply the same idea one more time if we want to calculate the average value of 4 variables for each given respondent. For example, for respondent number 1, let's put these 4 values together to reach a sum of 10, and then divide it by 4 because there are totally 4 valid answers, and then we reach 2.5. And if we follow the list-wise deletion way, all other 6 cases will generate 6 missing values for the calculation of mean value of answers to 4 questions, because we have at least 1 missing for each case. How about we treat this situation differently? We add up all valid responses together and divide the sum by number of valid answers. For example, for the second case, we put 2, 3, and 4 together. And because we have 1 missing value here, so we have totally 3 valid answers. So we add these 3 valid answers together and then divide it by 3. For case number 3, there are only 2 valid answers, so we put 3 and 4 together and then divide it by 2. For respondent number 4, there's only 1 valid answer, so the mean value will be this only valid answer. And for case 5 and 6, we follow the same idea to put valid numbers, valid answers together and divide it by total number of valid answers. And then we can have a better way to calculate mean value from these 4 questions. For the last respondent, because there's no valid information at all, so we set the calculation result of the mean value to be missing. I think this way is better than the first way of calculation mean value following the list-wise deletion rule to save your sample size. Okay, so this is a very brief introduction of missing pattern. Let's see how to get this job done in Stata. Close this Excel file and double-click on the SOC 5070 Stata 1 and 2.do to launch Stata. And let's scroll down to row 469. So this is the last topic of data cleaning and manipulation part 2. First of all, let's set up the working directory to be the desktop. So highlight row 474 and run. And then let's start a new log file to record everything we will do. And then we launch the data by run row 488. First of all, just like what we did last time in the previous video, we will have to reverse the coding scheme of 4 variables first before we can generate a meaningful scale score. So use the user written command revrs, which you have to download to your system before you use this command. And let's highlight the row 491 and run. So you will have 4 new variables, which are actually reverse the coding of the original 4 variables. Okay, so if you want to see a pattern, a missing pattern in your data, you can go ahead and click on the data browser button here, or simply go ahead and run the row 494. Okay, they will give you a spreadsheet, and then you can scroll from left to right, from up to down to see the missing pattern here. I omit this part. I leave this practice to you. The core here, in order to generate a sum that and treat missing value as 0, there are 2 ways to get the job done. The first one is to use the egen command, okay, followed by the a new variable name equals row total. This one is a built-in function to calculate total of these 4 variables row by row and treat missing value as 0. So let's highlight this row 499 and click on the do button. And then let's list the frequency table of this new variable close underscore sum. You will see that this new variable starts from the value 0. And we have so many cases with value 0. The reason of so many 0 here for this scale question is that by default, the function row total treat all missing values as 0. So if a respondent provided no valid answers at all to these 4 questions, then the row total will return 0 as the sum. This is something little bit different than what we want to achieve. To solve this problem, how about we add an option called miss to the row total function in the egen command. By including this option, the behavior of the function row total will change a little bit. If someone provided no valid answers to all 4 variables, then the row total will not return 0. Instead, this time it will return missing. So how about we highlight row 504 and run. And then let's list the frequency table of this new variable close underscore sum underscore m. So underscore m means that this variable contains missing value. So click on do button, and this time you will see the sample size is way much smaller than the previous example, and totally 77 cases provided no valid answers to all 4 questions. All 4 variables are actually excluded from this frequency table. So that's the reason why we have only 1261 cases left. This is actually what we want to achieve. So one more time, in order to achieve the goal, we need to use the command egen followed by a new variable name equal row total. Please spell this in full, row total, followed by the list of variables that you want to add up together within a pair of parentheses. So as a reminder, you also need this miss option so that cases with 4 missing values will be treated as missing in the calculation result. Another very useful function for egen command is row min. It's actually trying to calculate the mean value of 4 variables within this pair of parentheses, calculate the mean value of these 4 variables for a case, and repeat it for all other cases. Okay, so this one generates the mean value of these 4 variables case by case. There's no need to include any option. Cases with 4 missing values here will have a calculation result of missing. So how about we highlight the row 509 and run, and then we highlight 510 to list the frequency table of this new variable close mean. This is the mean value of 4 variables. You see that this case total sum of valid cases is a 1261, which is identical to this one. Okay, so that means cases with all 4 missing values will have a calculation result as missing. So this is how to achieve our goals in Stata. And actually, egen is a very powerful command. In addition to calculate a total of variables and the mean of variables, it can also calculate median of variables as well as maximum and minimum value within a list of variables. So it's a very powerful command. And if you want to learn more, you can issue help egen, and there are so many real examples for you to follow. And we will talk about the advanced usage of egen in my advanced stats course. That's everything that I want to cover. So before you leave, remember to close your log file by issuing the command on row 532, and then clear the memory by run the clear command on row 540. This is the last video of data cleaning and manipulation part 2. Thanks for watching. See you next time.